In this video, I'm going to be talking about the adaptations of the body systems to training. I will be analysing a centre player in a game of netball. A centre player in netball works anaerobically and aerobically throughout a game. In a game of netball, the centre player works anaerobically when they perform the following movements: jumping for an intercept, fast sprints around the court, driving towards the ball, completing a dodge, holding a 3-foot mark, and quick changes of direction. And then in a game of netball, the centre player works aerobically when they are walking, jogging, and just general running up and down the court. Throughout the game, the body is working anaerobically for bursts, but is mainly working aerobically due to the length of each quarter in netball. The intensity of the netball game can vary depending on the position you're playing. For example, a shooter would work more anaerobically, whereas a centre player, which is who I'm going to be referring to throughout the video, will mainly be working aerobically. This is because the position of them is that they can go all the areas in the court, so they'll be helping the attacking side as well as the defending side, meaning that they are constantly having to run up and down the court. The duration of a netball match does vary depending on age groups and other factors, but a competitive game of netball lasts an hour. A whole game is split into 4 quarters, each lasting 15 minutes. In between each quarter there's a break where players can rest and take on fluids such as water. An individual competing in this sport would need to be reasonably fit, as it's a very fast and high intensity game with a reasonably long duration. Increasing your aerobic fitness allows your body to be able to participate in the activity for longer and maintain your skill level during a match. I'm now going to be talking about the FIT principle and how it relates to netball training, aerobically and anaerobically. So FIT stands for frequency, intensity, time and type. The FIT principle would be applicable for anaerobic improvements. The frequency of the training for anaerobic improvements would be around 3 days a week. The frequency of training varies depending on the level of ability and fitness of the individual. The netball training would occur every day apart from Sunday, as Sunday would be the rest day and time for the body to recover. Training days will alternate between anaerobic and aerobic training. One day will be anaerobic and the next will be aerobic. The intensity of anaerobic training would be high. This is because when someone trains anaerobically, maximal power and force is generated to complete the movements and also no oxygen is available. The time, also known as the duration for anaerobic training, would be short. The time is very short because the movements are done at such a high intensity it cannot be kept up for any longer than 7 or maximally 9 seconds. Unless the anaerobic movements are at a slightly lower intensity, which is moderate intensity, where the duration can be around 2 to 3 minutes. The type of training will be specific to netball. A netball player will train all aspects of fitness but pay very close attention to anaerobic exercise because of the nature of the sport. The FIT principle will be applicable for aerobic improvements. The frequency of training for aerobic improvements would be around 3 days a week. The intensity of aerobic training would be low because when training aerobically, the intensity has to be low because the duration is so long. Also, when we work aerobically, not much power and force is being generated, so the intensity is low. The time for aerobic training varies. It can last anywhere between 20 minutes to many hours. It has a very, very long duration. Aerobic training can last a lot of hours due to the low intensity and the constant supply of oxygen. And finally, the type of training for a netball player playing in centre would be focusing on aerobic exercise as well as anaerobic, because throughout the game the aerobic system is being used, as each quarter in netball lasts around 15 minutes, meaning that the anaerobic system would only be used for 3 of those minutes, and so the player would mainly be working aerobically. I'm now going to be talking about the different types of training that would help improve a netball player's performance aerobically and anaerobically. There are 4 different types of training which could bring about different training adaptations. These include plyometric, continuous, interval and fartlek. So, Plyometric training, which is this one, is mainly anaerobic. This type of training is mainly involved in improving strength and power. Plyometric training involves and mainly improves the speed at which muscles shorten. It involves a lot of bounding, jumping, hopping, etc., when the muscles are having to work concentrically, which is the jumping up, and eccentric, which is the landing. Power, speed, coordination, and agility are all improved, which really is important for a netball player's performance. This type of training is perfect for improving anaerobic aspects of netball, such as intercepting and jumping, but I'll talk more about that later on in the video. So, continuous training is about trying to maintain and improve aerobic endurance. Due to the length of the netball game, continuous training is very effective at improving performance. This type of training should be carried out at a steady rate at a low intensity from around 20 minutes to around 2 to 3 hours or more. This type of training would improve aerobic performance in netball. The training would mean a netballer would have better aerobic fitness, so would be able to participate in the game for a longer duration and at a higher intensity without getting tired. They'd be able to run around more on the court and have more energy for movements such as jumps, interceptions, and drives. Fartlek training is good for both aerobic fitness and aerobic and anaerobic training. This training is good for aerobic fitness because it's an endurance activity. It's good for anaerobic fitness because of the speed at that the activities are undertaken over a short period of time. Throughout the exercise, the speed and intensity of the training is varied. This type of training is effective for netball players because it combines a range of training speeds and intensities, which would be applied to a game situation, as during a netball game, the speed and intensity varies a lot. Fartlek training would improve a netball player's anaerobic performance by increasing speed, agility, and power for explosive movements, as well as aerobic performance, maintaining stamina. Fartlek is a combination of sprints, jogs, and walks, which is continued for prolonged periods such as 20 minutes or more. This type of training would improve netball dodges, drives to the ball, sprinting, and jogging around the court. And finally, interval training. Interval training can also improve both aerobic and anaerobic fitness. It's called interval training because there are intervals of work and intervals of rest. For training the aerobic system, there would be slower intervals, which makes it suitable for the sports such like netball. When training the anaerobic system, there should be shorter, more intense intervals of training. If we were training for aerobic fitness for netball, you would exercise for around 5 minutes, then have a short rest. For example, running for 5 minutes or so, back and forth the length of the netball court, then they'd have 30 seconds of rest, and then they'd run for another 5 minutes. But if we were training anaerobic fitness, the individual would run at a sprint for 30 seconds, have around 30 seconds to a minute, at a very high intensity, and have around 15 seconds rest. Interval training would help improve sprints around the court, general anaerobic fitness, drives towards the ball, dodges, etc. Interval training has some aspects which are similar to a game of netball. For example, in netball there's a constant need to change pace between jogging and sprinting. Now I'm going to be talking about what adaptations will have happened as a result of the training. There will be many adaptations to the aerobic system's cardiovascular system, respiratory system, neuromuscular system, energy system, and skeletal system. I'm first going to be talking about cardiovascular adaptations from training. So, regular, continuous, interval or fartlek training helps to improve this cardiovascular system. Your cardiovascular system's ability to utilize and use oxygen is enhanced. This is because the amount of blood containing oxygen is increased, meaning that more oxygenated blood will be going to the muscles to be used. This mainly occurs due to the heart going through a phase called cardiac hypertrophy, meaning that the heart doesn't have to beat as quickly to get the same volume of blood around the body and to the working muscles, so the heart muscle doesn't have to work as hard. As a result, the body's heart rate will decrease, so an individual will be able to run for longer duration at a higher intensity due to the substantial amount of oxygen being taken to muscles. Cardiac hypertrophy is when the size of the heart increases due to the thickening of the wall called the myocardium. The heart becomes bigger and stronger due to training. The increased strength of the heart results in stronger, more forceful contractions. This means that more blood is being pumped out of the heart with each single contraction, and so therefore the body will be receiving more oxygen. Athlete's heart is also known as athlete's heart syndrome. It usually occurs in endurance athletes who train regularly, usually more than 1 hour a day. The human heart is enlarged and the resting heart rate is lower than normal. It is the idea that a trained athlete's heart will differ from an untrained athlete's heart, or untrained person's heart, in its structure and functions. The left ventricle experiences hypertrophy because it has increased size. This leads to the lowering of systolic blood pressure and an increase in cardiac output. This is because less atrial pressure is required to pump a greater amount of blood through the aorta. The increased heart size increases the stroke volume as more blood is being ejected from the heart per beat due to the stronger contractions because the muscle has grown stronger, or the heart muscle has grown stronger. The stroke volume increases while the heart rate decreases. The heart rate decreases because the heart isn't needing to beat as many times to pump blood around the body as more blood is being ejected per beat, which is the stroke volume. The increase in stroke volume and the decrease in heart rate is known as bradycardia. This leads to a larger cardiac output. The cardiovascular system becomes more effective at delivering blood with the oxygen and nutrients to the working muscles. The heart rate range gets larger because training will decrease an individual's resting heart rate, and the maximal heart rate always stays the same. The trained athlete's heart will start to lower because they have trained and experienced cardiac hypertrophy. More blood is being ejected per beat, and so the heart rate doesn't need to be as high, so the heart isn't having to work as hard. A trained athlete will be able to work much harder for a longer amount of time, as they will reach their maximum heart rate at a later stage than an untrained athlete. An untrained athlete won't be able to work for as long and for as hard. Won't be able to work as long for as hard at high intensity. If the heart rate is starting to lower, this means that there will be a greater range from the resting heart rate to the maximum heart rate. Maximum heart rate depends on the athlete's age. For example, it's always 220 and then minus the age. So for example, 220 minus 17 is 203. So that would be the maximum heart rate. Capillarization is when a capillary density increases. It occurs during exercise. There's an increase in blood capillaries. This therefore enables a higher oxygen uptake. As capillaries provide the working muscles with oxygen and removes carbon dioxide. Having better capillarization means that more diffusion can occur and therefore more oxygen will be getting to the working muscles and carbon dioxide produced in the muscles will be removed at a faster rate. It is vital that there is a removal of waste products such as carbon dioxide because the build-up of it can affect performance and also it can cause the onset of fatigue to occur quicker. Red blood cells transport oxygen and carbon dioxide through the bloodstream. With training, the amount of red blood cells in the blood increases. This means that more oxygen is being transported to the muscles and carbon dioxide is being removed from the muscles more effectively. Red blood cells contain the protein hemoglobin. Hemoglobin binds with oxygen and carbon dioxide for transport around the body. There's an increase in hemoglobin after training. The more oxygen that is available, the higher the intensity we can work out and the longer the duration. Blood volume consists of red blood cells and blood plasma. Blood volume increases with training, which therefore increases the size of the left ventricle, because more blood is entering it per beat, meaning that the stretch of the ventricle walls is increasing, so it becomes stronger. An increased blood volume means that more blood is being pumped to the heart, and so therefore more blood is being pumped out of the heart per beat, per minute. The increase in blood flow results in the blood volume in the body increasing as well. This means that the heart isn't having to work as hard to pump blood around the body. Plasma is a straw-coloured liquid that carries red blood cells. Plasma is made up of dissolved proteins and water. Exercise raises the amount of protein in the plasma. If there is more proteins dissolved in the plasma, the blood volume will increase. The increased volume of plasma results in better oxygen availability and circulation because the blood can flow through the vessels more easily. The viscosity of a liquid is to do with the thickness. With training, it is said that the blood viscosity decreases, meaning that the blood can flow more easily through the vessels. A decrease in blood viscosity is a good thing, as blood flow around the body is easier and quicker. The more viscous the blood is, the more resistance that is encountered, resulting in a higher blood pressure. Aerobic training can help to reduce changes of some cardiovascular diseases, such as hypertension, coronary heart disease, and atherosclerosis. Hypertension is also referred to as high blood pressure. It is a medical condition where the blood pressure within the arteries is always high. When the blood pressure is too high, extra strain is placed on the heart, blood vessels, and other organs. These are some long-term effects of having high blood pressure, which include stroke, heart failure, and heart attacks. However, regular aerobic exercise helps to reduce the blood pressure. This is because exercise makes the heart stronger, because the heart is a muscle, meaning that the heart doesn't need to work as hard to pump blood around the body. And if the heart isn't having to work as hard, the force of blood on the arteries decreases, and therefore the blood pressure decreases. Coronary heart disease is a disease where the substance plaque accumulates inside the coronary arteries. This is a problem as the arteries supply oxygenated blood to the heart. When the plaque builds up in the arteries, it's called atherosclerosis. Two ways to reduce CHD, coronary heart disease, include lowering your blood pressure and cholesterol levels. Aerobic exercise will make the heart stronger and blood circulation better, resulting in a lower cholesterol level and a lower blood pressure. I'm now going to be talking about some respiratory adaptations. So, ventilation will decrease with submaximal intensity exercise because a steady pace is being carried out and therefore oxygen supply is being met, or the demands are being met, and so the body doesn't need any more oxygen than it's getting. But with maximal intensity, aerobic exercise, the ventilation will increase because of both the tide volume and the breathing rate increases, therefore meaning the ventilation has to increase to keep up with the oxygen demands. As the duration of the exercise continues in submaximal exercise, the body increases the breathing rate. The breathing rate increases so that more oxygen can be brought into the body and delivered to the working muscles. Over time, the individual's breathing rate who is doing aerobic exercise will increase. This results in the breathing rate decreasing. With training, respiratory muscles become stronger. The strength and endurance of external intercostal muscles and diaphragm improves. With aerobic training, the endurance of the muscles improves more than the strength does. But with anaerobic training, the strength of the muscle improves more than the endurance does. If the muscles have more strength, it means that they can perform a greater contraction, meaning that more air can be breathed in per minute, so more oxygen is being brought into the body for the working muscles, and so therefore fatigue occurs later. The lungs increase their ability to expand, meaning that a larger volume of air can move in and out of the lungs. If more air is entering and leaving the body, this means that the body is more effectively taking in oxygen for the working muscles and removing carbon dioxide from the muscles. A trained athlete would be consuming a greater volume of oxygen per breath in the recovery period, meaning that the length of recovery is even shorter than for an untrained athlete. This is because more oxygen is being brought into the body per breath during an activity due to the increased strength and endurance of the respiratory muscles. This means that the epoch size is smaller. The epoch size for a trained athlete will be shorter than for untrained athletes. The oxygen deficit is the amount of oxygen the body wanted but couldn't take on board. How much of the effort was anaerobic, basically. For aerobic exercise, the oxygen deficit is very low because enough oxygen is being taken in and is meeting the body's oxygen demands because the body is working aerobically. The oxygen deficit for a trained person would be lower than an untrained person because they would be taking in more oxygen per breath than an untrained person. This is because their respiratory muscles would have better endurance and they would have stronger respiratory muscles. The alveoli is where gas exchange takes place and where diffusion occurs. With aerobic exercise, the number of alveoli in the lungs increases. This means that more gas exchange can occur as there will be a greater surface area for the gases to diffuse across. Aerobic training increases the rate at which gas exchange and diffusion happens. Diffusion happens at a faster rate because with aerobic exercise, capillaries increase in size. This means that more blood can travel through them, so more diffusion can occur. If more blood is flowing through the capillaries, this will mean that more oxygen is being carried to the working muscles. Also, capillarization occurs. This speeds up diffusion as new capillaries developing improves the extraction of oxygen. And finally, because there is an increase in hemoglobin in the blood, this means that more oxygen is being carried to the working muscles. Aerobic training can reduce the chances of getting respiratory diseases such as chronic obstructive pulmonary disease. This disease is a condition in which people struggle to breathe. It occurs when the lungs start to become inflated, damaged, and narrowed. By doing exercise, it can improve these symptoms, lowering blood pressure, strengthening the heart, improve circulation, and increase energy levels, a way to improve and reduce the symptoms, so that you become fitter, meaning that you can last longer without getting tired and short of breath. Some neuromuscular adaptations that occur with aerobic training include, so with aerobic training, slow oxidative fibres have an enhanced capability or capacity to summate. This means that this means to fire many impulses in target muscles all at once. Summating is improved with power and strength training. This is because, with training, it requires the maximum activation of target muscles to make the force that is required or wanted. Slow oxidative fibres can be trained by using them repeatedly, so the more the training that occurs, the more the slow oxidative fibres are able to fire more impulses to target muscles, meaning that the force is being generated, enabling an individual to generate more power, enhancing aerobic performance. Also, with training, these fibres become more fatigue resistant and are able to contract faster. This results in an individual being able to perform for a longer duration at a higher intensity. And finally, with training, mitochondria and myoglobin also adapt. Myoglobin is responsible for carrying oxygen in the muscles. With training, there's an increase in myoglobin stores. Myoglobin stores increase from partaking in submaximal exercise repeatedly. An increase in myoglobin stores enables a better performance because an increase in myoglobin means that more oxygen is being carried to the muscles, so the muscles are getting more energy and so can work for a longer period of time. And then with training, there's an increased number and they're bigger in size of mitochondria. The function of mitochondria is to produce energy from respiration. The more mitochondria a muscle fiber contains, the more fatigue resistant it is, or the fiber is. Same with myoglobin stores, the repetition of submaximal exercise improves the size of mitochondria stores. An increase in mitochondria helps with performance, as the more mitochondria there are, the longer the muscles can go without fatiguing, as the energy the muscles need is provided by the mitochondria. Now I'm going to be talking about the energy system adaptations to exercise or training. From training, there is an increase in the level of aerobic system enzymes. This means that slow oxidative fibers can resynthesize ATP better, meaning that an individual can maintain longer periods of aerobic exercise. There'll be an increase in the amount of oxidative enzymes, for example, pyruvate dehydrogenase, made inside the muscle cell mitochondria. This means that there'll be more activity in the Krebs cycle and the electron transport chain, so more ATP will be being resynthesized. So more energy will be made at a faster rate, so therefore an individual's performance will increase as they'll be able to work at a higher rate, a higher work intensity, and for a longer duration. There is an increase in the use and stores of fat. This increase in store means that more fuel will be available as energy for an individual when they are working aerobically. The adaptation is that fats are used earlier on in exercise, meaning that the glycogen stores are being saved. Glycogen is saved so that it can be released, then used for high intensity work, and also muscle fatigue will be delayed. Because fats can provide energy for high intensity work as well as glycogen and carbohydrates can. Glycogen sparing is a muscle cell's response in the specific muscle cells of the person partaking in aerobic training. It leads to fats being used earlier on in the exercise, meaning glycogen stores are being saved. OBLA stands for the onset of blood lactate accumulation. Lactic acid builds up when the body is working anaerobically, and it starts to accumulate in the muscles and eventually leads to fatigue and pain. When it starts to build up, the body tries to clear it, but can't. The lactic acid in the muscle increases the acidity, and that can lead to glycolytic enzymes being inhibited. This results in the lactic acid system not being able to be used and the aerobic system being used instead. And finally, I'm going to talk about how the skeletal system adapts. So aerobic training can bring skeletal benefits. So for example, continuous training or whatever. So for example, endurance running. By regularly doing long distance running, the risk of getting osteoporosis is reduced due to the fact that muscles will be getting stronger and will be able to withstand impact, as when you're running, your skeletal muscles do take a lot of force due to the constant strain on your muscles throughout the running. This graph shows OBLA, the onset of blood lactate accumulation. I'm going to explain how training aerobically benefits an aerobic performer. OBLA is always measured at 4 millimoles of mercury. The graph here shows an athlete reaching OBLA and their lactate threshold pre and post training. The red line represents post training, and the blue line represents pre-training, so before training and then after training. The pre-training athlete reaches their lactate threshold much earlier than the trained athlete. This is because the lactate doesn't build up as fast after training, as the body can remove it faster due to the increase in oxygen levels. Before training, the athlete reaches OBLA earlier than after training. It is worse to reach OBLA earlier, because it means fatigue will kick in sooner due to the lactate building up. The athlete post-training is able to work for a longer duration and at a higher speed. This is before stopping, because the lactate is being cleared from the body more effectively, and the body is able to tolerate it more because the body is used to it. So with training, the individual will have better performance, as they'll be able to work for longer periods of time at higher intensities before having to stop due to fatigue kicking in.